Today, we're going to be solving a triangle using the law of sines. However, this is going to be a special case that we call the ambiguous case. And you'll see in just a moment why we call it that. Now, let's take a look at this triangle. I'm going to call this triangle ABC, where the capital letters denote the angle measures of each one, and then little a, little b, little c. When we're dealing with the law of sines, we always write the lowercase letter opposite to that of the capital letter, which represents the angle measure. Now, in this triangle, we're going to have letter C, capital C, to be 36 degrees. Side B is going to be equal to 30, and side C is going to be equal to 27. Now, in this problem, we're going to be searching for angle measure A. So we're going to figure out what that is. And we're going to run into a tricky part in this problem. I'm going to show you how we overcome that. Now, this is how we know that this problem is the ambiguous case, meaning we're going to get multiple different solutions here because we're given a side, and an angle measure right here. Call it SSA, side angle. And so that's how you know that we're going to be getting multiple cases. And when we have SSA, we're going to get 4 different options. Option 1, we're not going to get a triangle at all. Option 2, we're going to get one unique single triangle. Option 3 is that we're going to get a right triangle. And then option 4 is that we get 2 triangles as our solution. So to solve for angle measure A, we're going to use the law of sines. So let's set this up. The sine of A over A equals to the sine of B over B equals to the sine of C over C. So that is the law of sines. Now, a pro tip here is that whenever you're trying to solve for something, you need to have only one unknown variable. So what I'm looking for is angle measure A, capital A. Now that means I need to have 3 other pieces of information in order for me to solve for it directly. Keyword directly. Now let's take an inventory here. Little a. I don't know what that is. That's not a very good start. That's already 2 question marks. Angle B. Well, I don't know what that is either. And little b, yes I do, it's 30. Angle C, yes I do, that was 36. Little c, yes, that was 27. So if we're going to try to solve for angle A, that means that we need to pair this one up with another one of these 2. Remember, in the law of sines, you have 1, 2, 3 different parts, but we're only ever going to use 2 at a time. Now let's take a look. Well, I have 50% of the information for B. I have 100% of the information involving the C's. So if I set sine of A over A equals sine B over B, that's 1, 2, 3 question marks. This right here is completely impossible for me to solve. Now let's try the sine of A over A equals to the sine of C over C. 1, 2, 2 question marks. It's impossible to solve for A directly here using the law of sines. So a lot of students will encounter this and they'll stop and they'll freak out. They'll not know what to do next. But here's what we're going to be doing. We're going to take advantage of the fact that if I add all 3 angle measures, they're going to add up to 180 degrees. Okay, I know that fact. But here's how we're going to go about this. Remember I said we only need 1 question mark. I can achieve 1 question mark if I set the sine of B over B equal to the sine of C over C. That's the only thing I can solve for in this problem. But you might think, but wait a moment, aren't we solving for angle measure A right here? Yes, we are. But if we solve for angle measure B first, meaning I'm going to know what angle measure that's going to be, then I could use the fact that I have 36 plus whatever number I'll figure out, plus this other number must be equal to the 180. So that's the game plan here, and that's where things could get a little bit tricky, because although it says solve for A, we're actually going to be using B in order to help us find that. So let's go ahead and set that up over here on the left hand side. So we're going to set up the sine of B over B equals to the sine of C over C. Now what I'm going to do is that I'm going to solve for angle measure B, and we're going to eliminate little b on the left hand side by multiplying. That's going to leave us with the sine of B equals to B multiplied by the sine of C, all divided by little c. Now this is the important part. I'm going to get that the sine of B is going to be equal to, I plug in little b, 30 multiplied by the sine of angle C, which is 36 degrees, all divided by little c, which is 27. So now I enter this into the calculator. 30 times sine of 36 divided by 27. That's going to tell me that the sine of B is going to be approximately 0.653. Now this number is actually really important for us, the 0.653, because this is what the equation is telling us so far. When I take the sine of a certain angle measure, it's going to give me a decimal value of approximately 0.653. Well, we need to figure out what values of B will give us this decimal approximation. Well, this is called the ambiguous case because there are two angle measures. We just don't know them yet. So let's figure out one, and we're going to figure out the other one. So whenever we're solving for an angle measure here, and we're using sine equals to a number or a fraction or whatever it is, this is what we're going to do. We're going to do a few steps. We're going to take everything right here, 0.653, and we're going to put it where the angle measure B is currently right now. We're going to take the B, we're going to drag it out to where the number is. So that's one step. Two steps. Your third step is that we're going to call this the inverse sine. So let's do that up here. All together in those steps, this is what we're going to get. We're going to get the inverse sine of 0.653 is going to be equal to my angle measure B. So like I said, we put the decimal or the fraction, whatever you have, inside the input for the sine. And then the angle measure B came out to where that number was, which is why it's on the right hand side. And we have to call it the inverse sine. Now, when you calculate this in your calculator is going to give you an angle measure of B is going to be approximately 40.8 degrees. This is very, very important for us. That means angle measure B has an answer of 40.8 degrees. But we need to wait a moment here, because what I said earlier was if I input the sine, we'll forget this one for a moment, the sine of this number, if I take the sine of 40.8, that will give us approximately the 0.653. But like I said, that's not the only angle measure. The other angle measure we can easily figure out if we do 180 minus this 40.8. Now, if we do that subtraction, we're going to find the second answer for angle measure B. That's going to be 139.2 degrees. Here's what that tells us. It tells us that angle measure B can actually be 40.8 degrees, or it can be 139.2 degrees. That is what this is telling us. And this is why it's called the ambiguous case. Because if these two answers are valid, then I can build two triangles here. And so this is one of those four cases where we get two triangles. But let's actually check, how do we know that both of these angles will work? Well, let's think about it. Let's take each case. Like I said earlier, I know that they all must add up to 180 degrees, all three. So let's start 36 degrees plus, let's take the case that B is 40.8. Plus some other angle measure here, we'll call it X now, plus X degrees must be equal to 180. We have to ask ourselves, is there enough angle measure left over for there to even be an angle measure A? Well, in this case, yes, there is. It's going to be 103.2 degrees. So that means that's one triangle. One triangle has the angle measures 36, 40.8, and 103.2. That's case number 1 because we only used this angle measure for B. Now the second case is if we had still began with the 36 plus now the second possibility, 139.2, plus still this unknown angle measure for angle A has to be equal to 180 degrees. Is there enough angle measure left over? The answer is yes. And here we're going to get 4.8 degrees. And that is the second triangle, or the second solution here. So that tells us that we have two solutions. And the measure of angle A is equal to 4.8 degrees or 103.2 degrees. That would be my final answer here for this problem. So I hope this problem helped clarify the ambiguous case whenever you're working with oblique triangles. Thank you for watching, and I will see you in the next one.